On Tuesday, NASA astronauts Butch Wilmore and Suni Williams landed their T-38 jet at the launch and landing facility here at the Kennedy Space Center in Florida. The CFT crew returned from Houston, where they were continuing their quarantine after the scrub of the first launch attempt on May 6th. Since then, mission teams worked to resolve various items with the rocket and spacecraft. The crew is now in quarantine at the Neil A. Armstrong Operations and Checkout Building while awaiting Saturday's launch, but not before taking a distanced selfie with some of the folks out there, some Boeing employees, out at the old shuttle landing facility. Welcome inside to the TV auditorium here at the Kennedy Space Center. I'm Daryl Nail with NASA. I'll be your moderator for today's pre-launch news conference. The second attempt of NASA and Boeing's crewed flight test of the Starliner spacecraft is scheduled for exactly 12:25 and 40 seconds a.m. Eastern Time on a ULA Atlas V rocket, which just returned to the pad yesterday morning at Space Launch Complex 41. Our panel today, got a fine group. Joining me to answer your questions, starting from my left, our NASA Associate Administrator Jim Free, Steve Stich, Manager of NASA's Commercial Crew Program. Dana Weigel is here, Manager of NASA's International Space Station Program. New to our panel, NASA astronaut Mike Fincke, the backup pilot for CFT and prime crew pilot for Starliner 1, the first rotational flight for NASA and Boeing to the ISS. We also have Mark Nappy, a Boeing Vice President and Program Manager for the Commercial Crew Program. Gary Wentz is the United Launch Alliance Vice President of Government and Commercial Programs. And Mark Berger, CFT Launch Weather Officer with the 45th Weather Squadron based at the Cape Canaveral Space Force Station. Of course, we're joined here in the room by members of the media as well as on the phone. We will take your questions, of course, following a brief opening statement by each of our panelists. And we'll start right now with Jim.
Thanks, Daryl. Good afternoon, everybody. Thanks for joining us again for our next attempt to launch the first crewed element of the Boeing Starliner family. We certainly learned a lot more about the system since our first launch attempt on the 6th of May. The teams have, as always, continued to work diligently to ensure that when we do launch this test flight, we're ready to conduct it safely. You've heard all of us on multiple occasions mention that we'll fly when we're ready. The teams have been taking the right steps to conduct the necessary testing and analysis to get us ready, and you'll hear a lot more about that today. We talked last Friday and then encouraged many of the folks of these teams to take some time off, spend some time with their loved ones over Memorial Day and be rested. Folks returned Tuesday ready to tackle the launch week and have continued their work that you'll hear in more detail about. That I'll let Steve and Dana discuss and others as they get into the details about holding our agency flight test readiness review on Wednesday, which was chaired by the Space Operations Mission Directorate Associate Administrator Ken Bowersox. And there the teams brought a number of analyses and go-forward plans to the elements you've heard about, from the valve replacement, the helium leak, and the fault tolerance. And we brought it to that Delta flight test readiness review because we wanted the whole team to hear and consider the evaluation and acceptance related to the CFT affected systems and overall system that are really based on our interim human rating certification plan, all that package that Steve will talk about. We are continuing to learn. That's what spaceflight is about. Every day we learn, both on our vehicles like Starliner on space station, with the ultimate goal of keeping our crews safe, going to, living there, and returning. As I mentioned, we're going to keep learning from this test flight, and I'm looking forward to us increasing our knowledge and understanding of this new spacecraft and overall system. Just a reminder, and I'm not stealing Dana's thunder here for ISS, but for more than 23 years, we've had people living and working off of this planet, truly changing the course of human history, in my opinion. The orbiting laboratory has hosted 3,000 research investigations from 108 countries. It's a critical testbed for everything that NASA is trying to do to understand and overcome the challenges of long-duration spaceflight. The research and technology demonstrations conducted on ISS, and some of which move through move through CASIS, are done so with benefiting life here on Earth. But they also will help us and are helping us prepare for those missions beyond LEO, the missions that will be for commercial LEO, and those missions that will take us to the moon and onto Mars. So thank you again for being here. And with that, let me offer my sincere thanks to every individual that worked to get us back here. That includes the crew who participated in a lot of the discussions, who understand what we've worked since then, but it's the individuals, it's the people that make space very special and help with the focus of keeping our crews safe. So let me thank them individually for their work. With that, I'll turn it over to Steve.
Thanks, Jim. Thanks for those kind words. And I want to thank all of you for being here today. Thank you for your interest in the Commercial Crew Program and our crewed flight test. It's been a busy few days, even since we last talked to you last Friday, and we kind of gave you an update on Friday. As Jim said, on Wednesday, we had the Delta Agency Flight Test Readiness Review, where we went through the readiness of several important aspects of getting ready for the flight. We talked about the helium leak and the P2D2 flange, and we went through that with the board. Also, our vulnerability to the deorbit methods, which I talked about on Friday. We talked that topic. We talked about a potential parachute crossover topic from a Blue Origin flight that occurred recently, and I'll talk a little bit more about that later. And then we made sure we had a good plan with United Launch Alliance for the operation of the self-regulating valve at the pad. I know it's been a long road to get here. It's really exciting for me to be here. It was exciting for me to, I got here just after Butch and Suni arrived on Tuesday, and it was great to see them here. When the crew arrives, we're getting close to launch, and of course we got the vehicle at the pad now. I'm very proud of the teams that have worked very hard over the last 2.5 weeks. As Jim said, we were able to get a little bit of downtime over the long Memorial Day weekend. I could tell when we came back on Tuesday, people were more rested and really ready to go to hit the final phase of operations, getting to launch. As we said, we're on track for the June 1st launch. 12:25 Eastern is the launch time, and we'll dock about 25.5 hours later at about 1:50 p.m. on Sunday, June 2nd. If we have to scrub for some reason, we have a backup opportunity on Sunday, June 2nd with a launch time of 12:03 Eastern. And then we would stand down for a couple days and have backups on June 5th and June 6th. It's great to all be here on the panel. I would tell you a few things that we worked over the last few days, and Dana will go into more detail. We received some data from SpaceX on a reflector on ISS that showed during some of their Dragon approaches and the port relocate that there was some degradation in the return signal from one of the reflectors. So SpaceX provided some data to us. We took that data and gave it over to Mark and the Boeing team. They ran a few simulations to make sure if that reflector weren't there overall, we could go ahead and dock successfully with the Vesta rendezvous navigation system. So we did that in the interim, and kudos to SpaceX for sharing data with us. I think one of the things I'm starting to see now amongst all these entities that are flying in space is a sharing of data back and forth, which has been incredible. I mentioned Blue Origin had a recent human space flight, a suborbital flight, where they had a parachute that did not fully inflate. Starliner uses some similar components to that parachute system in terms of reefing line and reefing line cutters that cut that parachute system. Blue Origin provided some data from their flight, shared it with the NASA, shared it with SpaceX, shared it with Boeing. We were able to meet and go through the particular components on Starliner, and we made sure we had good separation from that particular parachute that didn't fully inflate. We went through and looked at all the data, and that's good to go fly. And then finally, one of the last things we worked was there was a component on station, and Dana's going to talk more about that needed to be sent up, and we repackaged some cargo on the Starliner and are flying up about 140-pound item for Dana and the space station that really needs it. So we had to manifest some of the cargo on Starliner, and that was done today. I think what I've seen out of the Boeing and NASA team and the ULA team working with our space station team is a lot of agility in the last week at dealing with these things as they come up, which tells me that we're really ready to go fly, and we'll take it one step at a time and watch the vehicle. Mark will talk about the weather. We have a really good shot at the weather, and we're just going to watch the onshore flow a little bit. And other than that, we're ready to go fly when the vehicle and the crew's ready. I'll turn it over to Dana.
Thank you, Steve, and thank you all again for being here today. Let's see, Wednesday's agency review was really thorough. Obviously, we had a lot of discussion about the helium leak and also about fault tolerance. I think the Boeing, the Commercial Crew Program, and all the technical teams did a fantastic job bringing forward a thorough discussion on the flight rationale. I feel like we have a really solid mission plan to go fly this flight. From a station standpoint, our responsibility is really what we call integrated safety. That's safety of the two vehicles as they operate together through rendezvous docking, the joint mission and also undock. Those issues specifically don't really change the risk to that integrated operations space. It's really a subject for deorbit, as Steve mentioned. We did hold our ISS mission management team readiness review yesterday morning. Everyone pulled go, including the international partners. As Steve mentioned, we got surprised by an onboard anomaly this week. On Wednesday morning, our urine processor assembly, or UPA, had a pump that failed. That urine processor takes all of the crew's urine and processes it in the first step of a water recovery system. It then sends it downstream to a water processor, which turns it into drinking water. And so station's really designed to be closed loop and to have the urine processed continually all the way through down to drinking water. And so with that processor failed, we're in a position where we have to store urine on board station. We can do that to a certain extent. We've got bags and tanks that we've got up there for this purpose, but we've got limited inventory. The intent is really to recover and get the equipment going again. In this case, the pump that failed was really expected to run until about the fall timeframe, and we had our next spare manifested on the Northrop Grumman cargo flight that goes up in August. And so it failed a little bit early, which put us in a position where we'd have to store an awful lot of urine. Obviously, adding 2 more crew members to that further constrains the storage capability we have on board. And so we worked with the Boeing team, our ISS team, and our CMC Leidos cargo teams for a quick change to the plan for the Starliner manifest. So on Wednesday, we flew the ORU out here to Kennedy, got it to the launch pad. As Steve mentioned, it's quite large. In its packed configuration, it's in a bag that's about 3 feet long by 20 inches by 20 inches, and it's about 150 pounds total. So pretty substantial size, and the key for the flight was not to perturb the mass properties. So we wanted to keep the mass and the CG of the overall vehicle the same. So we worked to find cargo we could offload or displace without impacting that. And we ended up pulling off 2 crew suitcases. Those have clothes on them. It's funny, you're used to all these technical terms. Suitcases, just like we would take on a vacation. We do have a lot of generic contingency clothes on board, so not an issue. The crew's just going to use that instead of the specific items that are going to fly up. But huge kudos goes to the whole team for the quick response. I mean, they turned this around rapidly. So the flexibility from the Boeing team, from the ISS teams, and the cargo teams was just outstanding to get us to this point so that we could capture this launch opportunity and send up this critical spare to station. We will put it in pretty soon after the vehicle arrives. Obviously, we want to get that capability up and running again. Other news on board Space Station, let's see, on Tuesday, the Progress 86 vehicle, or 86P, undocked. That freed up the port for Progress 88. That vehicle launched just yesterday. It's in free flight right now. It'll dock tomorrow morning, Saturday, around 7:45 Eastern time, so about 5 hours before the CFT launch. The crew on board is working through EVA preparations. We have a series of spacewalks we're going to do this summer starting around June 13th. So they'll continue working through that. If Butch and Suni are up there with us during that time frame, we'll still conduct the EVA. We can also move them if we need to for any Starliner critical activities that would have priority over those EVAs. So from a station standpoint, from our crew, from our ground teams, we are ready to go fly this mission, and we're excited that we are on the doorstep of this historic mission. With that, I will hand it to Mike Fincke.
Good afternoon, everyone. It's good to be back here. Captain Wilmore, Captain Williams, Butch and Suni, they're veteran astronauts and my dear friends. We've been training together for a long time, and more importantly, though, for this mission, the crew flight test, they're test pilots, and they are looking very forward to getting flight test data that will help continue the certification process for Starliner, so that Starliner 1, 2, 3, and to infinity and beyond can fly and provide services to the International Space Station, and depends on it's up to Boeing, but other missions available out there too. So they're very excited for tomorrow's launch. Butch and Suni, they haven't seen the capsule since I took them to the launch pad, and then we scrubbed, so it wasn't me. But they haven't seen the capsule since they strapped in on May 6th. So they're actually back in the capsule. They should be there right about now for some comm checks to make sure that all the comm systems are working. They're talking through the TDRS satellites and making sure MCC, the Mission Control Centers in Houston, the Boeing Mission Control Center here in Florida, as well as with the United Launch Alliance. So we're all talking to each other tomorrow. So, but they're also going to take a sneak peek and get reacquainted with the capsule, especially with the new cargo configuration. So that'll just make everything ready, even more ready for tomorrow. I can say that they've been in quarantine for since end of April. They're very excited to go launch soon. But it's been a great process, learning more about Starliner along the way. And the more we know about our spacecraft, the safer and more successful we are with our missions. And so Butch and Suni, I've talked to them, and they have every confidence in our rocket. They have every confidence in our spacecraft and in our operations teams and in our leadership management teams. And they are definitely ready to go. And speaking of our spacecraft, over to Mark Nappy from Boeing.
All right, good afternoon, and thanks for joining us. The teams are on station, and they're monitoring the spacecraft as we sit here and talk to you. They reported this morning at 3:30, powered up the vehicle, and have been in a continuous monitoring mode, and will continue to work the launch preps and the launch countdown, leading up until tomorrow morning at 4 a.m. when the launch team will come in and start supporting the mission. So far, there's been no issues that we've been working with the spacecraft, so all's going well. Yesterday, we performed the L-2 briefing, and the purpose of that is to close any open issues and I should say, look at the changes that have happened since the May 6th launch attempt and make sure that we've got those all closed and taken care of. That meeting was successful, and we got a go poll to proceed to launch. Today there was an L-1 crew briefing. That went well also, and so we are ready to support going down into the launch countdown starting tomorrow at 4 a.m. We look forward to flying this mission. This is a test flight. We know we're going to learn some things. We're going to improve, and that improvement starts with Starliner 1, Mike, for your mission, and it'll be even better than the mission that we're about to fly. So with that, I'll turn it over to Gary.
Thanks, Mark. So we're very excited to be here today, preparing for our first human spaceflight launch to deliver Butch and Suni to the International Space Station. The rocket's at the pad. We're doing our final launch preparations today, as Mark talked, making sure everything's working between the launch vehicle and the capsule. For the majority of our team, today's a crew sync day, so they're getting set because the team comes in at 1 in the morning to start the launch count to fuel the rocket and support it to Mars launch. So everything's going smooth. We're not working any issues, and want to take this opportunity to thank the NASA and Boeing teams for working with us to get through the past couple weeks since May 6th, and looking forward to launch tomorrow. With that, I'll turn it over to Mark Berger, our launch weather officer.
Right, thanks, Gary. So we're heading into June, and it's an early afternoon launch attempt, so oftentimes if you're familiar with Florida weather, that would often mean thunderstorms. So no such concern for tomorrow. Generally local weather and weather down the ascent corridor over the Atlantic look quite favorable for us. That being said, there is one watch item, and that is the local winds. You may have noticed it's already turning breezy out of there with sort of a stiff onshore flow, and that's what we'll be monitoring for tomorrow as well. So taking a look at the numbers here on the forecast graphic, 90% chance of go weather, again, not considering any rain or thunderstorms, maybe a few clouds, but not anything concerning for us. Again, as mentioned, the winds will be a little feisty tomorrow, not only in terms of the magnitude of the winds, but also the direction of the wind. So again, a pretty good onshore component nearly perpendicular to the coast. So that tightens or restricts us just a little bit in terms of favorability. But again, now winds, as you know, are highly variable factor both in time and space. So hopefully we'll be able to get off without a hitch. Looking at the backup opportunity for the next day on Sunday, again, very similar weather conditions, although luckily winds do ease a little bit. So not only in terms of the magnitude, but the direction becomes a little bit more southeasterly or east-southeasterly, which is not quite head-on to the coastline. So again, that gives us a little more latitude as well. May pick up a few more clouds, but otherwise very favorable conditions for, again, early June.
All right, thank you very much, Mark. And I want to make one correction. If I said AM at the beginning, I meant PM. It's 12:25 and 40 seconds. PM. Don't show up here overnight. You'll only be eaten by bugs. All right. All right. We'll take your questions beginning now here in the room at Kennedy. Please raise your hand, state your name and affiliation, and to whom you are asking the question. We'll start with Marcia.
Probably for you, Steve. Are there any changes to the game plan since a month ago? Is it still planned to be an 8-day docking to the space station? And by my count, that would be the earliest coming back on June 10th. Does that sound right?
Yeah, right now I'm just looking. I knew you would have that question, Marcia. So right now, the mission's going to be about 8 days long, right, to fulfill all the objectives. We talked about some of the things we want to do, some manual piloting and some habitability. We want to demonstrate the ability to do what we call safe haven, which is the crew get in Starliner in the event simulated there's a problem on ISS. We'll do all that. But the earliest landing would be around Monday, June 10th. And that would be an undock around, this is Central, 4:50 a.m. Central. Landing at Wilcox would be the first one around 10:16 Central. And then we have a backup on June 11th at White Sands, and that landing time would be about 5:35 Central Time. So, but again, what we want to do is, once we get docked, we want to take the time to check Starliner out, check out all the systems, all the things we need to do for the long increment flight. And so I would say there's a chance that when we get to these opportunities, if we need to stay a little longer or we need to wait for the weather to get good, we'll stay up a little longer. So.
Irene, in the front here.
Thank you. Irene Klotz with Aviation Week. 2 questions for Dana. First of all, do you need the Progress 88 to dock prior to CFT launch? And for Steve, can you go over a little bit more detail about what happened with the NS-25 parachute and what the possible overlap is with Starliner? Thanks.
In terms of Progress 88, if they had a problem docking and they were in free flight past the time of launch, we would want to stand down to let them dock. Anytime you have a spacecraft in free flight, it's got a limited duration where it can just stay in free flight. And so it would have the priority. We'd go ahead and deal with whatever anomaly we had, finish the docking, and then we would get back into discussions about where to launch.
Yeah, I'll talk a little bit about what we have seen with Blue Origin. First of all, Blue Origin has done a great job of working with us and trying to understand what happened in that parachute test. Or that was actually a crewed flight, I'm sorry. One of the parachutes didn't fully inflate, and so the way a parachute works is it can have several stages of what we call reefing. And so initially the parachute doesn't fully inflate for loads. In this case, one of the parachutes was sort of stuck in what I would call first stage at some amount of the mouth of the parachute wasn't fully open. And so the way that works is there's essentially a line or a band around that throat of the parachute that keeps that parachute from being able to open fully. And what we saw is the cutters, for some reason, did not cut that line. And so it turned out we use a very similar cutter that Blue Origin uses, so it was important for us to look at that data. We went back and looked at all of our test data on our cutters. We've fired them like 160 times out of the lot that we're using, so we had good separation. We've never seen an issue with any of our cutters. All the testing was really superb on cutting the reefing line, and so that's why we proceeded to, we have good flight rational and good separation.
All right, Jeff, right here.
Jeff Faust of Space News. For Steve, looking ahead just a little bit, assuming we have a successful launch in the coming days and a nominal mission with no major issues, do you think there's still enough time to get Starliner certified in time to fly Starliner 1 in the first part of next year?
Yeah, I think that'll be something that we'll work on, after the flight. Right now, we're really focused on the crewed flight test and collecting all the data that we need. I think obviously the path to Starliner 1 clearly is the crewed flight test. That is the most important thing we have towards certification. So we'll go fly the flight, and we'll look at the data coming out of the flight, and then we'll make the right call relative to when we go fly Starliner 1. We have to go through this full certification. We really haven't had a chance. Mark and I have been super busy working the crewed flight test, so we haven't really had a chance to lay out that whole timeline yet.
All right, Joey, for our next question.
Thanks, Joey Riley for Reuters. For Steve, I just wanted to quickly follow up on Irene's Blue Origin question. Is NASA interested in learning about how Blue Origin's fixing that band issue? Do you guys open any kind of investigation into that, or are you continuing to work with them? Thanks.
Yeah, I would say Blue Origin has been outstanding. What we have found is like the parachute community between SpaceX, Boeing, NASA, and Blue Origin, it's a small group of people that really work on these parachutes. And so Blue is in the middle of an investigation. They've been great at sharing the data from us. They don't really have what I would call any kind of root cause yet, but we'll continue to follow along with them, our parachute team will.
And that's airborne systems that the suppliers that they all share?
Airborne makes the parachutes for all three. I don't really know who the reefing line cutter manufacturer is. So.
All right, Ken?
Hi, Ken Kramer, Space Up Close. Thank you, and good luck to everybody. Great rollout yesterday and remotes today. My question is for Steve and Mark Nappy. I'd like to ask some details about the helium issue, please. Can you tell us, first of all, what was the rate of loss? I've seen a whole bunch of different numbers, and I'd like to know that loss of helium, like in pounds, how much would it be, and what is the volume? What is the weight you have in the helium tank? I'd like to know, on a percentage basis, how significant is that helium leak? What is the margin that you have? Do you have more than one helium tank? Or does it go to different dog houses? So if you could talk in detail about the helium leak. Thanks.
Maybe I'll start and let Mark add in. So the leak rate we saw, I think we talked on Friday a little bit initially at the launch pad in this P2D2 thruster flange. We saw a leak rate of about 7 pounds per square inch per minute. And then we came back to the vertical integration facility, did some more testing, and the leak rate increased to about 70 to 80 pounds per minute. So, and keep in mind that leak rate, the volume is very small, so it's like 15 cubic inches of volume. So that's probably the size of a softball in terms of volume. So when we close the manifold valve, that's a real small volume, and so that leak rate will look pretty big. So that's the leak rate. We have roughly, I'm trying to think about how to characterize this in terms of the total amount of helium. We have margin of about, I would say, what we would call 500 psi of margin in the helium tank. The helium tank pressure is about 3,000 psi, so we have quite a bit of margin for the mission. This kind of size leak uses a small fraction of that. That's really our rationale to go fly. And again, we're going to power up the vehicle today, and then when we get it to the pad tomorrow, when we activate the prop system, we'll take a look at the leak rate. We can see that leak in the tank, actually. So we'll see if the leak's about what we expect it to be and see if Mark has anything to add.
Yeah, there's about 50 pounds of helium on board, and this leak, if it was left open to vent all the time, it would lose about 1/2 pound a day. So there's plenty of margin left over.
Well, 1/2 pound a day, but we're going to when we get docked to station, we're going to close the manifold, right? So we're going to isolate from the tank, as Mark said. So.
And it's one tank?
I believe it's 2 tanks. So.
Do they go to the different doghouse? Yes.
The two tanks are plumbed together, right? The tanks are together, and each of those 2 tanks has 2 manifolds that go to each of the doghouses.
All right, let's go to the phone lines, and Bill Harwood is on the line.
Yeah, thanks very much, and apologies for not being in the room with you. This is just a quick follow-up on helium, and I realize nobody expects anything like this to actually happen, but when do you pressurize the system for flight? In other words, when would engineers, get a chance to check that leak rate, just to have some context for the countdown? And finally, if the leak rate really did go up for some reason before launch, would the solution be to simply isolate the manifold at launch and go to your RCS-only deorbit scenario, or is there some rate that you just would say, I'm not going to fly? Thanks.
That's a lot of what we spent the last week or 10 days working on was all these contingency cases. So the teams have looked at when we open up these manifolds, and that's around T-minus 4 hours, so it's going to be around 8 o'clock tomorrow morning, and then that's when we would see if this leak has increased or not, and if it had increased substantially. The managing of the system is a lot of what the teams worked on over the last 2 weeks, is to, okay, what if it does increase prior to launch? What's acceptable? What would we do as far as troubleshooting? What would cause us to go back and reevaluate our flight rationale? All those conditions have been laid out for the launch team. And the same thing for flight. If we have an increase in leak, or if we have additional leaks, what's the criteria for what we would do? Those are all laid out in the flight rules. The teams have all been trained. The crew has been informed, and we're in good shape to fly.
Mark, I just add that the crew also spent a lot of time at the Boeing facilities in Houston to practice the contingencies. We're not expecting them, but in case they happen, our flight procedures and the crew will be able to safely come home and deorbit, and that was part of our risk trade-offs as we got closer to flight rationale.
Another question on the phone line, Micah Maidenberg. Go ahead.
Thanks, Daryl. Maybe you guys just touched on this a little bit, but Steve and Mark, regarding the design vulnerability and a plan to address that, having gone through the review this week, could you just explain one more time a bit more about accepting that risk, however remote, for CFD? Thanks.
Yeah, I'll start, and then we'll let Mark add to it. As we talked about on Friday, we have different methods of deorbiting the vehicle. We primarily use what we call the OMAC thrusters to deorbit with, and those are 3 OMACs per doghouse, and we got doghouses all the way around the clock, top, bottom, port, and starboard doghouse. It turns out for certain failure cases, we would lose OMAC thrusters. In other words, if we lost a helium manifold due to either the valve not working properly or some other line leak, which would have to be way bigger than what we're seeing in this flange, we would lose that doghouse. And then the way the software works is there's 3 OMACs there, 2 of them which would fire for deorbit, or maybe 1 if we use all 4 doghouses. The opposing doghouse, then the software says, I can't fire those OMACs because of asymmetrical thrust. And so it would really require the loss of 2 adjacent doghouses, the helium systems in 2 adjacent doghouses, say the top and port or the top and the starboard, to get into this situation where we need the RCS thrusters. So it's very low probability that would happen when we looked at the potential failure modes, but we have a way to get out of that, and that's when we would use this. If that were to happen in flight, which we don't expect it to happen, and we're managing the system so that we don't get into that scenario pre-flight, but we could use these 4 RCS jets to deorbit in the 2 burn sequence that we talked about on Friday. I'll see if Mark has anything to add.
Yeah, I talked to the process that we go through to come to these conclusions with safe flight rationale. There's a number of different disciplines that get involved, and we walk through these step by step, and the level of what-if questions that are asked is pretty amazing to make sure that we fully understand what's going on, what our problem is, what our solutions are, And what if we're wrong? And that is what took place over the last couple of weeks. Not only does our team with Boeing and NASA work this together, but we have independent people that come in, both from Boeing and from NASA, that looks over our shoulders to make sure that we're answering all these questions and addressing the issue correctly. So with that, besides being a very low probability that we'd get into this situation, we have very high confidence that the solution we came up with works.
All right, let's come back to the room, and the gentleman in the third row.
Thank you. Manuel Masanti, Exploración Espacial, covering the space program in Spanish. Last press conference, you mentioned that Boeing is thinking in a potential redesign of the propulsion system. So I would like to know, I think I did this question before, is this needs to be done before Starliner 1? If that's the case, how this affect the certification? Or it could be a potential delay on Starliner 1?
Okay. As far as a redesign goes, no, this would not be under the redesign. What I was referring to is that this leak has somehow sneaked its way through the system. What we suspect is that the seal was somehow either damaged during installation, or there was some debris in there that caught up and is not allowing the seal to seal properly. And obviously, we'd like to screen that before we get this far. So what we're doing for Starliner 1 is coming up with a screening technique that we can go apply to all the thrusters that are being built up right now for Starliner 1 to make sure that we don't have this same situation.
And then on the system vulnerability with the orbit, we would go look at, is there a way to maybe do a little more testing for those two big burns, hot fire in the thrusters, or is there a software change that would enable even more thrusters to fire? So.
All right, let's go to the phone lines real quick and get Stephen Clark. Stephen, go ahead.
Hi, thanks for taking my question. Daryl, Stephen Clark, Ars Technica. Just to follow up on an earlier question about the flight rule for the helium leak. When you pressurize that system at L-4 hours tomorrow, I guess the last time you checked the leak rate, it was 70 to 80 pounds per square inch. What would be the acceptable level of leak rate to press on with the launch tomorrow?
Turn to our resident flight director on the panel.
Yeah, we could manage about roughly a double the leak rate, and we can manage it in flight. What we'll do is we'll look at once the system is pressurized and open, we will be able to look at how much helium is being used from the tank. We talked about two tanks. Think of them as one tank because they're together. So we'll look at we know what that drop in helium should be per hour in the tank for this size leak. So we'll look at that to make sure it hasn't changed. And then if it has changed, we can go isolate the manifolds and then go take a look at this specific manifold and understand the leak rate there. And we've got criteria in place that says when we'd stop and talk about it or whether we're ready to go fly. So.
And Will Robinson Smith is on the phone. Go ahead.
Yes, hi. Excuse me. Thanks, Daryl. Will Robinson Smith with Spaceflight Now. So just to put a button on and follow up on Bill and Stephen's question. So if there were to be an isolation of the manifold, you would still be able to proceed with launch. Am I understanding that correctly? And is there a specific rate in the leak in which you would, feel more comfortable standing down and taking a deeper look at it? Thanks.
Yeah. As I said, so we'll go look at the leak rate, looking at the drop in the tank, right? And so we've got a criteria of about 20 psi per hour we're looking at before we would isolate manifolds to go at that kind of leak rate. If it's more than that, we would think maybe the leak has changed in our manifold, so we would go look at that. We wouldn't launch with the manifold isolated. Remember, part of the beauty of the Starliner system is it has an incredible abort system, and that abort system relies on needing all the OMAC thrusters, orbital maneuvering thrusters, in each of those doghouses. So we wouldn't launch with a manifold isolated. We could manage it on orbit. Should we get on orbit and see some change in the leak rate, we could close a doghouse As Dana talked about, we looked at the approaches to station, and it really doesn't, with the doghouse down, we can go ahead and approach station. It really is affects at the end of the mission, the deorbit capability. And then we really have a criteria up to 30 psi per hour in the tank that we wouldn't launch if it was above the 30 psi per hour in the tank.
All right, we've got a number of reporters on the phone, so we want to stay there for the moment and pick up Andrea Leinfelder.
Hi, this is Andrea at the Houston Chronicle. Thanks for the questions. I've got two. The first is from Mark Nappy. I know it just said that you'll look at certification after this flight test is back home, but you previously said that you're hoping NASA can certify Starliner by November or December. So I just need to know if that time estimate is realistic or if I should remove it from my article. And for Dana, I want to double check that Starliner is carrying 140 pounds of cargo to start to station. And the two crew suitcases that were removed, were they for Butch and Suni or folks on the station? Thanks.
Take the last one first.
Sure. We'll take the easier one first. Let's see, there's other cargo headed to station. What I'd say is the recent change to accommodate this urine pump, that bag fully packed is about 150 pounds. So that was what we had to do as a last minute change. Of course, there's other cargo that's on the vehicle. For example, the crew's got spacesuit parts and a few other things that are being taken up for us. The two specific suitcases that came off had clothes for both Butch and Suni in them, and also some crew specific, what we call hygiene equipment, so crew members can pick some of their own unique hygiene materials. Of course, we have generic hygiene, shampoo, soaps, etc. on board that they can just use from the generic supplies. Same with clothing. And so that's what they'll do. They'll just use our generic supplies that we have on board. And the reason why we have them there is for cases like this. In case a cargo resupply vehicle doesn't get there, we keep a certain contingency supply on board. And
now just the certification process. About 80% of the certification process, we know what we have to go do today and have been doing that over the last year. And that plan closes by November to have a certification review with NASA. The 20%, or maybe a little bit less, that's left over is reliant on the mission, on the CFT flight. There are likely going to be some kind of in-flight anomalies or things that we need to, data that we need to collect from the CFT flight. We have to download that data and analyze it and understand it, and that's going to be part of what we bring to the certification review, the results of that. So obviously the longer it takes to fly CFT, the shorter that period becomes for us to review that data and make sure that we have reports written and that we understand it. So that's the variable. How many in-flight anomalies do we have on CFT, and when do we bring the vehicle back, and do we have enough time to turn that around by November? If we don't, then we will move that review or do partial review. So that getting the certification review done as soon as we can is important, regardless of when we fly.
All right, back to the room. And Marcia, you're in the front.
Marcia Dunn, Associated Press. Two quick questions. Steve, how deep into June can you keep trying if things don't work out in the next week? And for Mike, when the crew is at quarantine in Houston, can they go home, or have they been stuck at not seeing their homes since the end of April? How tough has it been, this quarantine for so long?
Yeah, we have launch opportunities, as I said, June 1st and 2nd, the 5th and the 6th, and then I think we would have to talk with Gary and ULA. We've got to stand down for a number of days to do some replacements of batteries on the launch vehicle, on the rocket, and then I think we'd have to talk about what the opportunities were after that. So.
How long is that?
Gary can comment on how long it takes to replace the batteries.
So with the magnitude of the batteries we're looking at changing out, it's probably about 10 days.
So real quick about Butch and Suni and how tough the quarantine has been. It's so they were able to go back to Houston. We were able to do some training there. We do take the health stabilization program very seriously. We learned a lot, especially we all learned a lot during the COVID. But Butch and Suni were able to go home a little bit. We have to be careful about maintaining separation with the family. But Barry Wilmore, if you know him, he really likes to sit on his lawnmower and cut his grass. So I think he has the best manicured lawn in his neighborhood. And I know Suni enjoyed spending some time with her puppies, their dogs, and so they were able to get and that again, keeping the crew motivated and focused on the mission is important. So we were able to manage that with the flight docs, and then so they're back here obviously and ready to go.
All right, Irene, here in the front.
I'm not sure if this is for Steve or Mark or Mike as well. With the benefit of hindsight, if CFT had launched on May 6th and then the leak was discovered, was the understanding that there would have been an issue for a backup deorbit burn? Do you believe that would have been recognized, and was the solution to develop the 4 RCS dual burn, was that obvious, or does it only seem so now after you went through this and not in the heat of needing to get this crew home? I'm just trying to get a sense of what discovering this before launch sort of provides. Thanks.
Yeah, I'll start and then maybe let Mark add. I would say if we would have launched back on May 6th, we would have gotten on orbit and we would have seen this leak after we docked and closed the manifold. We would have seen this small leak. I think we probably would have gone through the system and we might have figured out that we had this vulnerability. It's really hard for me to speculate. I think we would have maybe seen it and figured out this solution that we came up with. I mean, the teams, when we found the leak, it didn't take very long to see that if we started talking about losing dog houses, that we had this vulnerability. So I think we would have understood it pretty well on orbit, and we would have then started looking at what the options were and see if Mark has anything to add.
Yeah, I'd be probably a little bit more forward on that. I'm 99.9% sure we would have caught it. As part of this troubleshooting, we built a fault tree that said this is where all the leaks could occur. And as we went through that is where we discovered this fault-tolerant issue. Had this occurred in flight, we would have had an unexplained anomaly coming home. We'd have built that same fault tree, we'd have gone through the same process, and we'd have learned the same thing. So I'm very confident we would have caught this.
Just to add 2 sentences, the process of developing the flight procedures and understanding with 8 RCS and 4 RCS, I think it was very similar to what we would have had done anyway. The only difference was that Butch and Suni were able to be there for the procedure development and for the testing out. Had they been up in space, then their trusty backups and Starliner 1 crew, we would have joined the team and helped with that. So it's we think we would have gotten to a similar, if not the same answer.
Okay, back in the front of the room, Joey.
Thanks. Question for Steve or Mark. Have you found out anything more about why you think the seal failed and led to the helium leak? Is that something you guys are continuing to be interested in? And then for Mark, if the delay goes beyond Thursday and the rocket has to have its batteries replaced, what on Starliner has to be replaced or replenished, if anything, and how long would that take? Thanks.
Start with the seal question. We are staying hungry to find out what exactly happened here. Let's learn as much as we can. So we have some doghouses that we're currently taking apart in the C3PF right now, and we plan on taking those apart and looking at those seals very closely to see if we can see anything that would give us more information about what might be happening inside of this one. So we will continue to look for the root cause and try to build evidence on what it is. We know it's the seal. We just don't know, was it damaged or was there some kind of debris in there with the leading causes, and we'll work to try to determine what that is or what that was. On the, so your second part of the question was on what is your best on Starliner if it goes beyond So the work we have on Starliner, we do have some limited life items that we would go take care of as well, but it all fits under the window of Gary's flight termination battery systems being changed out.
All right, back to the phone lines, and Marina Koren is on the line.
Hi, Marina Koren with The Atlantic. This is a question for anyone who knows the answer. What are Butch and Suni planning to have for breakfast tomorrow before launch? Thanks.
I'm supposed to know that answer, but I called them up today, and unfortunately they were headed off to the launch pad, so we don't have that answer. But I will assure you it'll be a delicious breakfast.
Okay, we'll take another question on the phone line. Anthony, the Spectrum.
Hello, thank you for taking our questions today. I'm just trying to, I guess, wrap my head around this, and I'm trying to use it in terms that most people would understand. If this was an airplane and there was a leak like this, I really don't think it would be allowed to take off. So I'm trying to understand why NASA and Boeing says, you know, we have a good backup plan here. We can launch this, but why don't we just play it on the safe side, roll it back, take the Starliner off the rocket, and fix the seal? Thank you.
I'll try to answer that, and we'll see what Mark has to add. I mean, I think, first of all, we looked really hard at what our options were with this particular flange, and the fact that this flange has a fuel line that goes into the flange and an oxidizer line and a helium line all going into the flange makes it problematic to work on. It makes it almost unsafe to work on. So what we really have taken an approach is for this size leak, when Mark talked about, it's a half a pound a day out of 50 pounds of total capability in the tank. I mean, it's a really, really small leak, and it's well within the margin that we have. And so sometimes for space flight, you plan for contingencies and you design the vehicle to have margin. And in our case, we have margin in the helium tank. And we've looked really hard and worked really hard to understand that margin and to understand maybe the worst cases. And we took the time to go through that data, and we really think that we can manage this leak both by looking at it before we launch, and then if it got bigger in flight, we could manage it. In fact, we could handle, as I said on Friday, a leak that's 100 times worse than this. So in this one flange. So when we looked at all that data, we concluded that the smartest thing to do was to go fly the mission, and we could fly it safely, and we would have the redundancy we needed. And I'll see if Mark has anything to add.
It's really just a matter of safety. When we looked at this problem, it didn't come down to making trades. It came down to, is it safe or not? And it is safe. And that's why we determined that we could go fly with what we have.
All right, another question on the phone. Leo Enright with Irish Television. Go ahead.
I think this is for Mike Fincke. Just wondering about transatlantic abort scenarios. I haven't seen any reference to a transatlantic abort zone, so I was wondering what happens. Can you talk us through it? And I'm assuming that this would be a water landing, and they're not going to parachute onto Shannon Airport.
No, we would not be landing in Shannon Airport. So there is a period of time over the North Atlantic Ocean, a spot over the North Atlantic Ocean. It's called the North Atlantic Exclusion Zone that we don't want to land because the water is always cold and wavy and dangerous. So Starliner, along with the dual-engine Centaur, has the capability of, once it gets near this exclusion zone, to head back towards Canada, and it flies kind of a burn, points towards Canada and flies back, and we call that a St. John's abort. And then if that's not going to work, we can continue the flight or continue, and we fly outside of onto the Irish coast in the water at a specific point. There's a guided entry sequence, and it'll take us close to Shannon, Ireland, right off the coast, and then hopefully, and we're counting on you for the Irish Coast Guard to pick up my crewmates, and then we'll get them back to the U.S.
Another question on the phone, Tim Fernholz. Go ahead.
Hi there. Thank you for taking my question. This one is for Mike. I was just curious for my readers if you could share the perspective of the astronaut office in the last week going through the analysis here and coming up to this flight rationale. What is your perspective on it? And I was also curious what it's like for an astronaut to fly in a vehicle that has a deviance like this. I was curious if that had happened in your own career. Thank you.
Yes, so from an astronaut perspective, one thing that I'd like to say is that, and we mentioned it here, the NASA Commercial Crew Program Office, as well as the Boeing Company, have included us and Butch and Suni and their representatives and all of our Flight Operations Directorate, and we're part of the team. We know what's going on. We understand the discussions and the risks that are being talked about for being mitigated. Butch and Suni especially have a very strong voice that if they were concerned about something, we would send it up through our chain to the chief astronaut who would take it forward. I think if you ask Butch and Suni directly, and I can answer for them, that they feel very comfortable and confident that we've chosen a good path forward. And as flight testers and as engineers, this is something that we know. It's giving, I don't say birth to a new spacecraft, that's a little dramatic, but when you have a new spacecraft, you need to learn all about it. And this has been a great exercise in understanding about all the nuances of a new spacecraft, as well as what are we going to do about it, how do we work together as a team. And this is a really good example of finding a tricky problem and coming up with solutions, answering a lot of what-ifs, and looking forward to saying, all right, how do we make sure this doesn't happen again? And all of those pieces are in place. And that's part of developing. This is development, not operations as much. And we see those same kind of things in airplane programs I've been involved with, as well as first times we got to the International Space Station. I remember I was there for that, and we were learning how things operated, and we learned what pieces were going to fail sooner than later, and we know our space station really well now. And we're going to get to learn Starliner through a lot of operations even better. So this is, I don't say par for the course, but this is what we do. This is how it is to develop a new spacecraft, and we understand that everything isn't going to be perfect, so what do we do about it? And we have good discussions and good understanding as we move forward comfortably, and the crew is a part of it, not just Butch and Suni, but all of us get a voice and get understanding. So we are excited for launch, and we're confident. We have every confidence in this mission.
Well said, Mike, and we'll end the briefing on those words. Thank you to our panelists for taking the time to join us, as well as the members of the media here in the room and on the phone. A reminder, the ULA Atlas V rocket with a crewed Boeing Starliner spacecraft is set to launch at 12:25 and 40 seconds p.m. Eastern Time tomorrow, June 1st. Coverage on NASA Plus and our website, nasa.gov/live, begins at 8:15 a.m. Eastern Time, with special guest star Mike Fincke is on the broadcast. So we looking forward to that. Should be entertaining as well as informative. Until then, everyone have a great afternoon and go CFT.